One problem with rocks within Vue is when you have a world material on it, in a world coordinate system, and you have a lot of rocks grouped together, you end up seeing features from the rocks grouping together and kind of transitioning between them. So darker spots, and not a lot of variation between the individual rocks. Now, there are some ways to vary it by setting up material to be based on slope. That does help, altitude as well. But I'm going to show you a really cool math node that will vary the origin and position offsets for pretty much every rock. And that way the material changes a lot more between rocks. So I'm going to go into my rock material by going through the world browser, selecting material and ecosystem materials to access anything we have in the ecosystem. I'm going to edit the function, and what I want to do is make it so that these different fractals are a little more distributed between each individual rock. So this is a node that is for ecosystem materials. It will only really work in ecosystem materials because it needs the variation of instances. What we're going to do is add a math node, and there's a couple of different nodes in this group, and these are the instance seeds. Instance seed number 2, and then also the distribution instance seed. Let's go ahead and use instance seed number 2. And already we have the ability to use this without connecting it to the top position. What it has is a couple of different offsets, 3 offsets and 3 origins. So we can either offset the position up at the top, which means we also need to connect it to that top position input. So what we can do is select some of these different nodes in here, and that multiply by a constant. Looks like we're going to need to have that connected as well, because we want the instance seed to be the last in the list. We could always use multiple instance seeds. What we're going to do is connect this top one to a position offset because we're connecting and distributing the position. We can use number 3 for that one, and position offset number 2 for this other node. And now to have more variation, because we don't have to have every single one connected with the position offset, we can also use the origin. So we can go to one of these fractals and extract the origin and connect it to one of the origin offsets. So anyone that isn't connected to the instance seed, we have one more here. We can extract the origin. We'll use origin 3, and it looks like they're both using origin 3, so let's go ahead and pick a different one. Let's use the top origin. The origin of the material itself can also be connected. Right-click, add an output node, and select origin on the bottom. So we could also connect that to the seed. And we're going to select origin 2. So now what this is going to do is offset the vector in order to provide variation between rocks. So now we can see a lot more changes within the material coordinates between the individual instances. Now this is a fairly complex material, so it does distribute well. even without the instance node or the instance seed. But with it, then we've got way more variation. And also, there are changes in the material sizes. One of the options, if we go back into the material and take a look at the node, is there are basically two options. You can have scale variations turned on, and what that will do is make it so that some of these different positions will also be modified to change the material scale. And it doesn't affect every single output, just a couple of them. And then we have a randomize, so we can modify it a little bit more. If maybe we like the distribution overall, but we want maybe a different pattern showing, you can use that option. In this render, I've moved the camera out a bit and reduced the density of all the rocks, cutting it down by about half, just so you can see the distribution from a little farther away. Now, this material is pretty even throughout the coordinate space, so I also want to show you with a material that is going to change color and darkness a little bit more. So go ahead, and I'm going to load in a different material for this. So the material I have the instance seed connected to now has the ability to go to pretty extreme ranges, much more than the last one, where we have the rocks and the material getting really light and then really dark in some areas. So with the instance seed connected, we see a nice distribution of the different materials, material origins, and material coordinates being applied to the different instances. Where normally we would just have a fractal that kind of blends in and out of each other, instead we have individual rocks being placed at different parts of the material coordinate. And these work best if we take a look at how I set this up. I'm using a color brightness variation with the position connected to the instance seed, and a couple other fractals connected to that. Pretty much anything that has a metascale turned on is going to give the best result, because it's allowed to have a more extreme value for dark and light areas. So grainy fractals work really well. The color brightness variations, all the variations have the grainy fractal basically built into it. And of course you can use terrain fractals and anything like that too. So if we take a look at the material preview, what it would normally look like, we would typically see smooth blends between the different zones and not those sharp cutoffs like we saw within the ecosystem. So you could also use this in combination with the eco-material variance in order to set up different color variations in different tones that way, by modifying the color output and kind of switching between maybe different filtered versions. So even with the connections we have already established, there are a couple of different color links we can connect to get some variation. So let's go ahead and add in a combiner node. And we're going to select the Eco Material Variance from the MetaNode menu. And if we just take a look at the color previews, we can see what we're going to get. So what we could do is just connect the different inputs to some of the different color options at different points within the function. So now we should have a nice color change along with the vector change taking place. And then if you wanted to change and modify the bump in different places, we could use a numeric dependent. since the changes are being mostly derived from the same color function, we're not seeing a huge amount of change. But if we wanted to set up color correction nodes with a HLS shift on each of the color connections, we could add even more variation. So what we could do is add in color node, color correction, HLS shift, and just connect that. We'll go ahead and use 2 of them so we can copy and paste and add them to our existing connectors. And then just change our values a little here. And now the color change is a lot more obvious. So now there's just enough of a shift in color in order to be able to really see it. We've got the lighter green spots, darker green, sort of purplish rock. It adds a lot of variation to these materials and really allows you to create ecosystems that you just wouldn't be able to create otherwise without loading in tons of different objects in order to make up for those material changes. So this way you can use one object and be able to distribute its material differently with a Boolean operator so that it is not just a halfway of one material bleeding into another, but actually just saying either we use this material or the next material or the third one in the list if it's the ecosystem or the eco material variance. Or with the seed, it's almost a different offset in material coordinates for every instance.